use. Again, remember, this is a great preview as to what you'll see on the Chapter 6 test. Okay, we're going to now solve some radical equations. This is good stuff right here. Really, really more advanced math here for you guys, so that's fun. So what we want to do when we solve with radicals is we want to isolate, solve, and then always check. You have to check. The check is not optional. The check is mandatory because an extraneous solution might show up, and so you want to make sure that you check all of your solutions, and that's even brought in down here as a reminder, and we'll probably do that way on the test too, I think, if we remember to put that in there. Okay, anyway, so let's isolate first. So minus 2, so 3x minus 3 equals 6. That's called isolate. Isolate first. Okay, and then we're going to square both sides. So I want to square and square. So 3x minus 3 equals 36. Add 3, 39. X is equal to 13. So you want to check this extraneous solution. Extra solutions can pop up. So you want to go back to the original and check this. Okay, is 2 plus 3 times 13 minus 3 equal to 8. Is 2 plus the square root of 39 minus 3. Okay, that's just 39 minus 3. 3 times 13 minus 3. Is that equal to 30? That's equal to 36. Okay, so is 2 plus 6 equal to 8? 8 equals 8. Yes. So that checks. X is equal to 13. All right. The next one here is a cubed root. It's already isolated, so I'm going to cube both sides. Y minus 12 equals 27. Plus 12 plus 12. Y is equal to 39. So let's check. Is the cubed root of 39 minus 12 equal to 3? Is the cubed root of 27 equal to 3? 3 equals to 3. Check. Y is equal to 39. Okay? Excuse me. Just FYI, you really don't even need to, when it's cubed, when it's odd, extra solutions aren't going to pop up. You don't really need to check those. But it's never a bad idea to check, so we'll do it there. It's really with the squaring both sides where the extra pops up. So, didn't have to really check this one, but never a bad idea to check. Okay, you got to check your even roots when you square or when you to the fourth. When you raise to an even power, that's when it's mandatory to check. But when it's odd, you don't really have to. But okay, so we're going to raise both sides here to the fourth. And so this is 2x plus 1. The 1/4 times the 4 just play knockout. They just knock each other out. And this is 81. So 2x equals 80. And so x equal to 40 here. So let's check it. Does 2 times 40 plus 1 to the 1/4 equal 3? Well, that's 81 to the 1/4. Does that equal 3? Well, 81 to the 1/4. Remember, rational exponents. This means the fourth root of 81. Is that 3? Well, certainly 3 times 3 times 3 times 3 is 81. So the fourth root of 81 is 3. Check. This is, where's my answer? X equal to 40. All right, so that is LTQ for, what, 6.5. Okay, so let's just take a look at that. So you can see everything. There you go. Good stuff right here. All right, next page, last page, I think. Okay, so function operations. All right, perform the indicated operation. Okay, so we have a function that's called f, a function that's called g, and this is just telling us to subtract f and g and then plug in. This is your plug-in. So you could plug 2 into f and see what that is. You could plug 2 into g and see what that is. and then subtract that, or you could subtract f and g and then plug 2 into that result. It's just whichever you want to do first. It's kind of personal preference there. So I'm going to just go ahead and do f minus g. So f is 2x minus 1, and g is all of this. So since it's two terms, I want to subtract it all out. Okay, so that's just f minus g. That's the f function. You could even put that in parentheses if that helps you see. That's f minus g. So 2x minus 1 minus x squared minus 3x. Okay, 2x minus 1 minus x squared minus 3x. Shakes out to be minus x squared minus x minus 1. And then I'm going to plug in 2. So negative 2 squared minus 2 minus 1. So the 2 just goes where this x is, so this negative is just kind of chilling out, waiting in front. The 2 squared there is just going to be that. Negative 4 minus 2 minus 1, which is negative 7. So maybe you like it to do that way, or you could do f at 2. So f of 2 is 2 times 2 minus 1, which is 3. And g of 2 is 2 squared plus 3 times 2, which is 4 plus 6, which is 10. You could do it that way. And then when you subtract those, obviously, f minus g, 3 minus 10 is negative 7. So, maybe you might like that better. Either way, it doesn't matter. The result is negative 7. All right. And then here, f times g of x. So there's nothing to plug in here. So this just wants this multiplication. So f is 2x minus 1, and g is x squared plus 3x. So that's a binomial and a binomial foiling situation. F O I L. All right. So 2x times x squared is 2x squared. 2x times 3x is plus 6x squared. X squared times negative 1 is negative x squared, and negative 1 times 3x is negative 3x. So let's clean it up. 2x cubed plus 5x squared minus 3x. That's what it looks like here. 2x cubed plus 5x squared minus 3x. All right. Okay, and then this is g over f, evaluated at 4. So if you want to plug in first and divide, or divide and plug in, it doesn't really matter here. Okay, so g over f is going to be g f. That's really all I can do there, and then put the 4 in. So that'll be 4 squared, which is 16. 3 times 4, which is 12. 2 times 4, which is 8, and minus 1. Okay, so this is 28 over 7, which is 4. So that result is 4. All right, in 6.6, domain restrictions. And so basically, what can I plug in for x? Well, I don't want a negative under here. So this can't be negative. So 3x minus 9 can't be negative. So to find the domain restriction is basically just telling you what x can't be, because I don't want a negative under there. Okay, so for example, if x was 1, this would be 3 times 1, which is 3 minus 9, that'd be negative 6. So x can't be 1. All right, so I don't want to go through every number in the world and figure out what x can't be. I want to do a little equation to find my domain restriction. So what's underneath the radical can't be negative. So it needs to be 0 or positive. So that's how you set it greater than or equal to 0. It could be 0 under the radical because the square root of 0 is 0, or it can be a positive number. So we just say 3x greater than or equal to plus 9 plus 9, divide by 3. X must be greater than 3. So this domain is X such that X is greater than or equal to 3. All right? And then here, basically this can't, if you have a denominator, you have two domain restrictions. You can't have a denominator of 0, and you can't have a negative under the root. So x squared minus 4 cannot be 0. So x plus 2, x minus 2 cannot be 0. So x plus 2 cannot be 0. X minus 2 cannot be 0. So x cannot be negative 2. X cannot be 2. So this domain is basically x, such that x is all reals, but x cannot be plus or minus 2. It could be everything else but plus or minus 2. All right? Whew. Okay, last one here, 6.7. Yes, 6.7. All right, inverses. Basically, the gist of an inverse is that x and y interchange. Okay, x and y interchange. So the inverse of this is going to be 3, 4, 7, negative 2, 3, 0, and negative 1, negative 1. All right? So points of the inverse would be, just rewrite this, 3, 4, 7, negative 2, 3, 0, negative 1, negative 1. All right, is the determine if the answer to number 1 is also a function, okay? So this is a function, so let's just look at the original. So you got x and y's here. So 4 maps to 3, negative 2 maps to 7, 0 also maps to 3, and negative 1 maps to negative 1. So this is a function. So as we talked about in class, you know, this would just, you have a little bit of overlap here, but this would just like be saying that someone with a 94 gets an A, or, you know, a 3, but 94, pretend it's an A 94 gets an A, and a 90 gets an A. That's okay. You can have two different x values that go to the same y. That's okay. But let's look at the inverse. So the inverse is 3 maps to 4, 7 maps to negative 2, and now 3, you know, branches out to also go to 0, and then negative 1 to negative 1. This is not a function. You can converge, but you can't diverge. I can't have, you know, a 93 be an A and a 93 be a C. I would get, you know, emails about that. That's not fair. That's not right. You know, it goes against the syllabus. So you can't have it diverge. You can have them converge to the same, but you can't have them branch out. So is the inverse a function? No. No. No, no, no. All right, to find a function, an inverse when you're given an equation, you want to just replace, go through the steps like we talked about in class. This is y, and so we just replace f of x with y. Interchange, basically you have your function right now. That is the function, but we want to solve it for y so that we can write it in this lovely form here with f inverse of x. So I'm going to interchange, we interchange them, now I'm going to solve for y. So I'm going to send the 3 over for negative 3. Okay, so just minus 3, I just moved that 3 over to the other side. And now I'm going to multiply both sides by negative 2. So this is negative 2x plus 6. And negative 2 times negative 1/2 is positive y. So there's your inverse, and then we just replace this y with this f inverse symbol here. This is this new notation that you learned, and that's just 2x plus 6. Okay, so you can expect problems very similar to this on your test. So practice, 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 and let's start off the semester strong with a good Chapter 6 score. Okay, bye guys. See you next time.